Hello, everybody. It's great to see so many people interested in Finagle and projects around it. My name is Vladimir, and this is the first time I'm speaking at SF Scala, but not the first time I'm talking about Finch, so hopefully it will go well. You're probably wondering who the hell this guy? Well, I'm the creator of the Finch library and a full-time Scala developer here at Twitter on a Finagle team. And to prevent your questions, no, I don't work on Finch full-time, and no, we don't use Finch internally at Twitter. Finch is just one of those pet projects we developers do in spare time for fun. So if Finch fails for you, don't blame me. I don't make any money of it. All right, what this talk is about. I'm going to give you a brief overview of the history of Finch. I'll show you its evolution starting from the 40 lines gist file to a full-featured library that is already used in production by several companies. And I'll mostly focus on the notable design decisions I and other contributors made. And who am I kidding? I'm going to talk about shitty things we did before Shapeless. So the current version is 0.6. We are currently kind of in the middle of the journey to the first stable version, but it feels right now that we found a great path that will make it to 1.0, which will hopefully happen this summer. So my talk is about where is it from and where is it now, and Travis Brown in the next talk will probably show you where is it going. So, and before we start, let me ask you a few questions. How many of you folks have heard about Finch before? Well, not too much, right? All right. So, and you didn't start it on GitHub, right? Probably. You know what to do. Almost an year ago, I was working on a REST API backend for a small startup. And in the very beginning, I wanted to use Finagle for this, since I just got a Twitter job offer and was trying to get familiar with the stack. But I quickly realized that bare Finagle HTTP abstractions are quite low level and rarely composable in the wild. And I also didn't really want to use Finatra for this, since I was trying to stay close to the Finagle bare metal API as much as possible. I was mostly thinking about something immutable, highly composable, simple and small. I was kind of trying to apply functional programming to Finagle HTTP and build something actually useful with it. Something that an average Scala programmer who basically doesn't know the category theory can efficiently use and, more importantly, have fun with. And before we start talking about Finch, let's see how we can use Finagle HTTP in the REST API setting. And how many of you folks are currently running Finagle HTTP in production? Not too much. All right, interesting. So it's going to be like a new thing for you, but I hope you'll catch up. So here's the typical Finagle service, or microservice, if you will, that emulates fetching a user by its identity. And first of all, we have to fetch a query string param name, which is an option, so we have to provide a default value for this. And this line looks okay-ish for Java programmers, maybe. As Scala programmers, we might want something better here, something like a composable function that takes a param name and returns its value, so we can reuse it and compose and not write this line every time. So we also have to build a response, a JSON response in this case. And so I love Finagle a lot, but I can't say the same thing about HTTP package. So we wrote 3 lines of immutable Java code to build a simple JSON response, which is quite verbose. And in Scala, we will likely want something like polymorphic function that builds an HTTP response depending on the argument type. Finally, that's how we do routing in Finagle HTTP. We have this fancy routing DSL available out of the box in Finagle. And overall, this looks pretty good and pretty solid. We extensively use Scala features here, like pattern matching to extract route details. But a routing service is just a service that you basically can do nothing about it. And we'll probably want something more flexible here, something that we can compose 2 things together to be able to reuse them and like do nested things if needed. So the bottom line is, while it's totally possible to use Finagle HTTP in the REST API setting, it doesn't really look like an idiomatic Scala style which promotes immutable and composable abstractions that's easy to reason about it. that's why I started working on Finch, which is a Scala idiomatic version of the Finagle HTTP. Finch is aimed to make life easier with Finagle HTTP, so if you're currently happy with Finatra, you probably don't need Finch. Finch is for those who are unhappy with Finagle HTTP. So, and the nice thing about Finch is it's not a framework, but a library. So you can incrementally integrate its primitives, which are just functional types, into any existing Finagle service. Finch doesn't force you to follow any concrete style on organizing your code base, like placing everything in the controllers. Frameworks usually do it. With Finch, it's totally up to you how to write your services and how to organize the code around them. And this fits pretty nicely into any existing service. So this GIST file, published a year ago, is the first ever version of Finch. And as for today, Finch is still a very young project, but it is rapidly approaching its first stable version. And this doesn't actually mean that you can't use Finch right now. In fact, most of the Finch users have started to use it from its early versions. Finch is doing a really great job on making its API changes smooth and most of the time invisible. So don't be scared of trying the current version, which is 0.6. Updating to 1.0 won't break your code much. So you're probably wondering why Finch. Yes, we love birds at Twitter, but Finch is an outside project, so I could pick any non-bird name. And in fact, the bird name happened here accidentally. I was thinking about a name that says both. It's about Finagle and it's about something really small. I was kind of hoping to build a small number of abstractions on top of Finagle HTTP, something like a tiny, teeny Finagle clone for a particular problem. And I found this combination, which is Finagle plus inch, and where inch is unit of length, pretty small thing actually. And it turned out it's a bird. So we have this beautiful bird on the logo right now. Yeah, by the way, I have 3 stickers. So yeah, we are not as rich as Finatra. We have only 3 stickers. I'm going to exchange for questions in the end of the talk, so be ready if you want one. So who is using Finch right now? As for today, 4 companies are officially using Finch in production. And also I have some information from trusted sources that at least 4 other companies are currently developing their products on Finch but haven't launched it yet. So if you somehow currently using Finch in production, please make it to the adopters list. Please keep the contributors motivated so we can continue making Finch more awesome. Well, the official part is over right now, and we are going to start looking at the code. And I have to warn you, I have like 40 slides with bloody Scala code we have to discuss tonight. And probably the best way to survive this talk is grab some beer and get a little bit drunk. And don't try to catch all the details, but focus on the big picture. Sorry. All right, the first abstraction that made it to Finch is an endpoint, which is a composable router, where the routing logic is encoded in partial function from HTTP request to service. So it exposes the only one method or else that takes 2 endpoints and composes them in terms of underlying partial functions. So we can use it like this. We group similar endpoints together and then merge them into a single endpoint, like a root endpoint. And this abstraction is pretty straightforward, since it completely uses the built-in Finagle routing DSL, although it's a pretty powerful thing actually, given there is an implicit conversion between an endpoint and Finagle services, so we can do sort of nested endpoints here. And this thing survived till these days, while there is already a replacement in Finch for this called Route Combinators API. Some people still use this approach, since it's just super simple and safe. The syntax is very intuitive, even for Scala newcomers. And some time ago, I got a feedback from a person who managed to write a REST API server with Finch having just a zero Scala experience. And this is pretty nice. Another early abstraction is a monadic request reader, which is a reader monad over the HTTP request. It's basically a function from an HTTP request to a future of something. And the reasonable question here is why it returns future, not try on option. Well, in the very beginning, we wanted to make it look similar to regular Finagle services, so we can sort of unify the API. And this worked great since the Finagle features are quite lightweight, given that we only deal with them with satisfied state, and the overhead of this feature is pretty low, but it simplifies other things a lot. So the first API version was quite verbose. There was a pair of 2 readers, required and optional, for every possible output type and every possible request part, like query string, param, header, body, and so on. So we had like 40 readers in total, but now it's just like 10. And I'll show you later how we managed to reduce the API surface while maintaining the functionality. That's how we build the request reader of type user using the monadic API via for comprehension. So this request reader reads 2 query string params, required param ID and optional param name. And the basic usage pattern looks exactly the same we use Finagle services. Since the request reader returns future, we simply chain them with flat map. So it should be clear now that if the request reader fails, we will have a future exception in response, just like from a regular Finagle service. There also was a special case of a request reader called validation rule that didn't really lead anything useful, but check if the given Boolean predicate is true. It returns an empty satisfied future if it's true, or throws a validation fail exception otherwise. And this looks stupid, but it's actually useful. And here's how. We can use it in for comprehension to compose it with other request readers and validate their output values. And there is no restriction here. We can chain any number of validation rules in the same for comprehension, and they will be applied sequentially. But bad news, this thing is not reusable at all. You will have to write a new validation rule every time you need it, since the predicate is a value, not a function. Usually it's not reusable until it takes a function as an argument. So, but bad news, there is a bad abstraction for this in the current version of Finch that we'll discover later. So remember how we built a JSON response in 3 lines of Java code? Well, a response builder makes it much less verbose by providing a bunch of polymorphic methods that build HTTP responses depending on the argument type. So it supports 3 response types: a text plain response, a JSON response, and a response with no content. And usually you don't speak to a response builder directly, but to its concrete implementation backed by HTTP status code. And it looks pretty simple. So we can treat response builder as just regular functions, so we can just call it. But the question here is, how can we support a new JSON library like Argonaut? Should we override an apply method on the response builder to support new JSON type? Well, actually, there is a better solution for this. A type class-based encoding. So we have a type class encode response that knows everything about how to convert an arbitrary type A into a string and how to send it over the response body. So we can replace all the polymorphic methods we had in the response builder with just a single method for arbitrary type A, for which there is also an instance of the response available in the scope. So it will has all the information needed to serialize any arbitrary type properly. And that's how we do JSON in Finch. For now, it supports 2 popular JSON libraries, like Argonaut, which is preferred for Scala projects, like pure Scala projects, and Jackson, targeted to better Java compatibility. But there is no limitation here. You can, with this approach, in just a few lines of code, you can define a support for a new serialization library, no matter if it's XML or JSON or whatever. So there is also an opposite situation when we have to be able to read the content of an HTTP request from the HTTP body. And for this purpose, we need some sort of string-based body readers, like required body and optional body. And in order to convert a string into some meaningful type in your domain, like user, you would have to apply a parsing function to required body reader, which sounds okay, but we can do better with type class-based request decoding. So we have a type class decode request that knows how to convert a string into arbitrary type A. So, and it also returns try, so we can handle all the errors properly. So we can pass an instance, of decode request type class into the body readers, so they would know how to decode an HTTP body directly to a required type. And no surprise here, that's how we do JSON decoding at Finch, with two different libraries. And once again, there is no limitation here. You can decode anything you want, as long as there is an instance of decode request available in the scope. So, in that moment, we realized that we can also apply the same approach to other things, not just HTTP bodies, like query string param headers and so on. So we can use the same API pattern for everything, which is quite nice. So, and to do so, we did two simple things. First of all, we provided implicit instances for all the output type, target type we wanted to support by default. And second, exposed this magic method S on a request reader, on a string-based request reader, so it can decode the underlying string into an arbitrary type. And this dramatically simplified the API of request readers, since we removed all the instances of request readers with hard-coded output type. And this is how it looks before type class-based decoding, and this is how it looks after, and this is how it looks today. So we moved towards simple and short names in the API, which is kind of popular story for the functional libraries. And the nice thing about type class-based decoding is that it's very pluggable. You can easily extend the functionality of all the request readers to support new output type by providing a corresponding instance of the decode request type class. And in this example, we define a new decode request instance for a type datetime from JOTA-time library in just a few lines of code. So we can now define a request reader that fetches a JOTA-time interval from the two query string param, start and end. And as we can see, type classes fit very nicely into the problem of type-safe decoding and encoding, and we use them quite extensively in Finch. So nowadays, the monadic API of the request reader look like this. And we've already discussed everything from here except for this default method that actually defined for optional readers to provide a default value for the underlying option. And this looks good, but the question is, do we always need a monad for that kind of things? Well, we actually no. While the API powered by language support looks nice, we lack the ability to properly handle the errors from the request reader. So the nature of monads is fail fast. So the request reader composed with monadic API will return the only first appeared error, which is a nightmare for front-end developers. But luckily, we have a better thing in Finch right now, which is called applicative API. So it consists of both the composite type tilde that wraps two values and the new compositor on the request reader tilde that takes two request readers and composes them into a single reader that basically read two values in parallel. And the API looks pretty nice due to Scala language support of the infix types, but this pattern matching here looks kind of ugly. And the question is, can we do better here? Well, what if I say that we can replace it just like this, which is pretty short? Well, and I have a good slide that explains how it's possible. So it's not that simple actually, but still, an arrow combinator allows us to treat a function of a type a tilde b tilde whatever as a regular Scala function. So what we do here is define an implicit class like arrow26 for every possible composite type we have. And this class we define a new method tilde that is actually implemented in terms of map and which does a pattern matching for us. And this looks pretty solid, but we are now trying to move this boilerplate code even from Finch. Something like to deep down to the stack to the libraries like shapeless and cats. And that's basically what we are trying to do right now. So the validation rule has also been revisited in the recent releases. We replaced that ugly version of the validation rule with backed by a request error of unit with this fancy abstraction that is basically a Boolean predicate that is composable in terms of logical OR and logical AND. So we also exposed two new methods on the request error like should and should not. So you can compose the request error with validation rule. And by default, Finch provides a bunch of reusable validation rules for both numbers and strings. And as you probably noticed, the request to your API now looks like a tiny DSL for request processing, which fits pretty nicely into the concept of functional libraries and functional programming. And here we define two request triggers that will fail with future of exception in case of unsuccessful validation. Speaking of the domain-specific languages, there is a road combinators API available in the current version of Finch. And the concept of this DSL is somehow similar to the concept of libraries Scala parser combinators or scodec, giving a plenty of predefined routers that know how to handle only a single part of the road, and you compose them with special functions called combinators to build complex things that solves your problem. So, and routers always extract something from the road. So it's basically a function from an abstract road to an option of both the remaining road and the extracted value. And all the built-in routers might be divided into two groups. Matching routers that extracts nothing, and extracting routers that extract something. For example, routers get and routers star are matching routers. They doesn't extract anything but match the given part of the road. And two extracting routers like int and string that extract int and string values correspondingly from the abstract road. So the road combinators API is very intuitive and lightweight. I don't think I have to comment this, but there is one thing I want to talk about. In this example, we compose two routers with or else combinator that basically says if the first router fails, use the second one. And this looks very powerful, but it's actually not. It only works if the types of two routers are the same, which doesn't really fit into the actual story. We usually don't serve only users or tickets or something on the same API server. We usually serve everything. And in order to overcome this, for now we force our users to unify their routers to use the same output type, which is Finagle service. So every router extracts an HTTP service that actually does a job. And this works pretty great, and more importantly fits nicely into the concept of how Finagle does it. Well, in Finagle HTTP, you usually deal with raw HTTP types directly via Finagle services from HTTP request to HTTP response. And no big deal, but these types mean nothing in your domain. When I say I want a service that returns a user by giving ID, I'm thinking about service or function, if you will, from integer to user, not about function from HTTP request to HTTP response. And so we lack all the type information behind these useless HTTP types, which is kind of terrible because in Scala types actually matter. And I think you would agree with me that types help us to better understand what's going on in the code. And just compare those two functions from int to user and function from HTTP request to HTTP response. It's clear that the first function maps an integer value to some user type. But what does the second function do? Well, who knows? Maybe reboots your server. I don't know. So that's basically what we're working right now. We want to make Finch more type safe by getting rid of those useless HTTP types, and so our users can finally see actual types behind them. And this should be possible with heterogeneous routers backed by shapeless. And I hope Travis will give you some more details on this direction in the next talk. But the idea basically is to allow users compose routers of different types, so they will have a router for shapeless HList. So also we want to allow our users to compose request triggers and routers together. So they will have this fancy DSL that looks like more like URL, not Scala code, which is very nice. And finally, we'll probably merge the functionality of both request trigger and router to have some sort of single abstraction for everything, which is kind of like simplification. So the bottom line is, Finch is the right tool for you if you wish to have highly composable functional primitives aligned with Finagle's scalability and performance. And I really like this tweet from Travis. It somehow explains where is Finch right now. It lies between these awesome Scala libraries and working really hard to combine them in a nice way. So here's the link to a GitHub page. Feel free to join, file an issue, or even send a pull request. And the last thing I wanted to say is just a quick reminder, I'm neither an expert in functional programming nor in REST APIs. I just made a yak shaving tool that I missed, and then other people found it useful for their problems, enjoyed the project. So we kind of started working together to build something actually useful and nice. And as for today, a lot of Finch contributors made a real difference in the project and contributed the mission-critical parts of the API. So if you kind of want to make the same difference, try it and leave a feedback, and we will work together to address it before 1.0. So thank you, that's all I have. Do you have any questions?
Do you have any strategies that you follow when, or I mean, maybe not you, but the users of Finch so far follow to build very complex interrelated systems using microservices? So thinking in terms of batching of collections and things like that for transmission on the wire and that kind of thing?
Yeah, so I would say that you can do with Finch anything you want as long as you can do the same thing with Finagle. It's basically like doesn't hide anything from Finagle. So it fits very nicely into the concept of how Finagle does it. So if you can do this batching thing with Finagle, you can do it with Finch. It just like makes some things more nicely for you.
Can I have a sticker?
Here is the first question.
Yes, sure. Whoa. Just 2 questions left. 2 stickers, I mean.
So you have a really nice abstraction with a request reader. What about for HTTP servers using Finagle that are talking to other HTTP servers? So like a response reader or like a reader-writer state?
Yes, that's a nice question. Thank you. We have a ticket in I believe on the next milestone that says it's your ticket, right? You have a sticker. That's a nice question. Yeah, it's about consuming HTTP services. So we kind of hoping to build something like response reader, or something like this, something really nice, something really composable that you can use. Yeah. Just one sticker.
I'm more of a Scala question. So you mentioned, hello? Yeah, you mentioned that you differentiated Finch from, it's not a framework, but a composable thing.
Right.
Do you restrict yourself to a subset of Scala features that you plan to use, or? The problem is, given the wide variety of features which is available in Scala to build composable services, do you restrict yourself in terms of code quality of the feature set of Scala to use it but not use that feature?
Yeah, we basically use, I believe, almost everything, I hope. Yeah, and now we're kind of trying to integrate more with Shapeless, which does every magic for us. So basically everything that Shapeless use, we'll use kind of the same pattern. Maybe Travis can say.
Yeah, if I could hijack the question a little bit. So we are using a Scala linting tool called Wart Remover, which does restrict the kinds of things. It basically gives you either warnings or errors if you're using lots of different Scala language features. So it goes even further than the language feature flags in Scala 2.10 or than the Scala linter itself. So yes, we are restricting the language quite a lot through the use of Wart Remover.
Right. Thank you. Here's your sticker. Oh. All right.
How simple are you planning to leave Finch? Because it seems like it's just really like some nice abstractions on top of HTTP.
Right.
But you also have integration with like OAuth 2, for example.
We don't really have it right now. There is a ticket about this, but there is a library which is called Finagle OAuth 2. I wrote it. Yeah, and it should be pretty easy to integrate it with OAuth 2 if you're talking about this.
Is it in your plans to make it bigger?
Make it bigger? No, I don't think so. We are not going to make it bigger. It should be like super simple, super like core abstraction that allows you to do basic things. It's a library, it's not a framework. There is one question there.
What was the monospace font that you used in the presentation?
The monospace font?
Yeah.
It's a presentation engine called Shower. If you Google it, Shower.js, and it's kind of like default theme. I don't know. I don't know exactly how. I'm not giving a sticker. Just one sticker left, guys.
Other questions?
Right, I probably give it to Ben. Thank you.